All right, so we are looking at day number 9, combining like terms and expressions. The first step, it asks you to circle our variable terms. So take a look at your paper and see if you're circling what I'm circling. I circled the negative 3k, making sure that my circle also includes that sign that comes before the negative 3. And a circle around the positive k. Now that little line that's right, that was just pasted up there on the screen, that's just where my cursor froze when I was drawing.
So if you're circling the variable, why are you circling the 3?
The 3 is the coefficient of that variable. Great question. So when we say we're circling our variable term, that includes the sign, the coefficient, and the variable. Now we have that 1 that's hanging out there on the end. We don't want to leave anybody out. That is called a what? Not a variable term. Very good. A constant. So I'm going to put a square around it. The directions say to put a square around it. So when you're combining like terms in an expression, you're adding your circles to your circles and your squares to your squares. So your variable terms plus your variable terms and your constant. Whenever you are combining like terms, you are always using the rule of adding integers, which we abbreviate with the letters SOB. For same signs, add. Opposite signs,
Subtract.
Bigger sign, wins. Yeah. Same signs, add, bigger. So let's take a look at our variables. Yeah. When you're combining your terms, we generally will combine our variable terms first and then our constants. So our answer, you should start off with your variable term and then your constant term. So let's combine our variable terms. We have a negative 3k and a what k? What is that? That k right there, what's its coefficient? I don't see it. Yeah, it's 1. I'm going to go ahead and write that in just to remind us that it is 1. So we have a negative 3 and a positive 1. Are those same signs or opposite signs? So if it's opposite signs, we have to subtract. Right? 3 minus 1 is 2. So I'm going to write that down, 2. But the bigger sign is what? Positive or negative? Negative, because the 3 is bigger than 1, and it's negative. It's a negative 2. Now we copy down the k, though. It's like saying, okay, if I have negative 3 kites and positive 1 kite, how many kites do I have altogether? Well, negative 2 kites. Okay. And then our constant, that 1, does it have any other like terms in that expression?
No.
So we can't combine it with anything else. You just write plus 1. Notice that I did write that sign on that 1. The only time you do not need to write a sign on a term is if it's called its leading term or the first term in an expression. Every term after that, you do need a sign, even if it's positive.
Why wouldn't it be 1 minus 2k?
1 minus 2k? Technically, that is correct. But it would be like me saying, my name is Stacy, which we're all used to hearing, or Stacy is my name.
Same thing.
It's saying the same thing, but generally we will write our variable terms first and then our constants. The most widely accepted way of writing your answers. So when you do write your answer, if you want it to be the standard form of the expression, you write your variable term and then your constant. So take a look at your second answer and see if you've done that. See if you wrote your variable terms first and then your constants.
Nope.
Okay, then try writing.
Second one, it's 0k.
All right, so let's take a look at these. X gets a what?
1.
Okay, you're going to put a 1 in front. Does it get a circle or a square, though? Circle. So it's a variable term. How about the 6? Square. It's a constant, and I kind of covered up. That is a negative 6. I apologize there. And then the 6 gets a square. And that negative x gets a circle. All right, we're ready to combine our like terms. We're going to start by combining our variable terms. You have a positive x and a negative x. Somebody said this already. What does this do?
Cancels out. That's wrong on. That's not the same as on our paper.
You have a positive x
No,
on,
we have a positive 6.
on the first one. Here, let me see if mine.
There's 2 positive 6.
Oh, it is a positive 6. My pen just covered it up when I colored over it. I apologize. So Yeah, that's a positive 6. There we go. Sorry, my pen just wrote right over top that positive sign, so we couldn't see it too well. All right, so let's first combine our variable terms. You have a positive x and a negative x. It's a 0 pair. So I'm just going to cross those off. When you combine those equal 0, and we won't need to write anything. Then you have a positive 6 and a positive 6. Those are same signs, so you have to add. 6 plus 6 is 12, and that would be your final answer, is just the 12. You don't need to write 0 plus 12 or 0 x plus 12. Our final example, let's go over circles and squares. Let me hear you real loud. First one, negative 9y.
Circle.
Positive 4.
Square.
Positive 2y.
Circle.
Circle. All right. So what are we going to have to combine first?
The 9y and 2y.
Okay, so our variable terms, the negative 9 and the positive 2y, are we going to add those two together or subtract them? Subtract. They're opposite signs. Excellent. So 9 minus 2 is?
Negative 7y.
So to be a negative 7 because the bigger sign wins y. And then plus 4. Just adds to the end. All right, in the second practice, we're combining like terms in an equation. Now, what's the difference then again between an expression and an equation?
There's an equal sign.
It's an equal sign. What's another rule we need to remember when we're combining like terms when you have an equation? Do you know this rule? You can't combine like terms unless they are on the, go ahead. No. How about they're on the same side of the equation? Okay? We cannot combine them unless they're on the same side. Sort of like, okay, I've got apples in this room here and apples in that room. I can't combine them unless I put them in the same room together. Okay? So think of it that way. So when you may have to move some of your terms. Let's do the first step on the first example. First, just by identifying our terms. Our x gets a...
Circle.
Oops, sorry, and my screen just went away. Just a second.
Are you recording this too?
Yep, I'm recording it. So if you guys ever want to play this back again, it'll be posted online. You can rewatch the audio recording again.
Are you going to put in Excel?
It's on Edline. Yeah, it'll be on. So our first one gets a circle, and that's a positive 4 here. My pen went over the positive sign again. Positive 4 gets a square, and the 7 also gets a square. All right, so I have, what are my like terms in that equation?
4 and 7.
4 and 7. I know I need to combine them, but what the problem is that they're on opposite sides of the equation. When I say opposite sides, use that equal sign as separating your left-hand side and the right-hand side. Some of you might draw a line to separate right down the middle of that equal sign, so you know the difference between the left and the right of your equation. Now, would it make more sense for us to move the 7 with the 4
No, the
or the
4.
4 with the 7?
4 with 7.
Yeah, because our whole goal is to get that variable all by itself. So when you're looking at this, a common mistake that I see students do is moving like the 7 with the same side that the variable is on. So we do need to move the constant that's with the variable away from the variable. Now, when you move a term, a circle or square, from one side of an equation to the other, or when you cross that line, you have to remember to do what?
The golden rule.
Okay.
Wow.
I'll give you a rhyme. When you cross the line, you change the sign. Okay? We cross the line, you change the sign. So we need to move that 4 to the other side of the equation. So we're going to subtract 4. Yeah. Because that's a positive 4 on the left-hand side. We're going to write a minus 4 on the other. I'm going to cross that 4 off, that positive 4, because it's no longer on that side. Just remember that was a square there. It was a constant. And now we're ready to combine our like terms.
Be 3.
What rule do you use when you combine like terms?
Subtract.
SOB. Same signs add, opposite signs subtract, bigger sign win. So we have a positive 7 and a negative 4.
Which would be positive 3.
Okay. And it's positive 3. And how did she get that?
You subtract them.
Okay. Are those same signs or opposite signs? I'm going to help her over here. 7 is positive, and 4 is a negative now, because we moved it over to the other side. Say -4 now. We had to cross that line, so we had to change the sign. Now that they're opposite signs, we have to, remember our rule, SOB? Yeah. You have to subtract. So 7 minus 4 is 3. And that's where they got that 3 from. And our x just comes down. Don't forget to write your equal sign.
So it'd be x equals 6.
So it's x equals 3, yeah.
Well, I did all these wrong.
Okay, let's look at the second example. -2 gets a square. It's a constant. Y gets a
Circle.
circle. And the 10 gets a square. Very good, you know this. All right, so what are the like terms we need to combine here?
10 and -2.
So when I ask a question, you're doing great. When I ask a question, I want you to think about it in your head before you say it. So let everybody give a chance, and then I'll kind of point to someone to answer. We have a 10 and a -2. Like what Robin said, those are the two like terms that we need to combine. But notice, are they on the same side of the equation as each other? No. So we have to move one of them. Which one are you going to move?
-2.
Yeah, the -2, we need to move it. When we move it to the other side of the equation, what do we need to write?
Change the sign.
Yeah, cross that line, you change the sign, +2. So I'm going to cross off that negative. We moved it to the other side, and now we're ready to combine. Now I need everybody to stop and not say a thing. I'm going to make sure you got this because I understand you had a little trouble on it before, so I want to help you. Not trying to pick you out, but just trying to help you. So if I have a 10 and a +2, I'm going to add those two terms together or subtract them? Add them. Because they are somebody out there?
Possibly.
Same signs. Because they're the same signs, we have to add them together. So 10 and 2 is 12. And we just bring down our y. Yeah. So y is equal to 12. Do plus y? You don't need to put the sign on that plus y. Yeah. And why not? Somebody, does this all understand? She said she put a plus sign in front of that y. Why don't you have to write the plus sign in front of it? And this
We already
is,
assume it's positive.
it is the only term on that side of the equation. If it's the only term or it's the first term in the expression on a side of an equation, then you do not have to write the positive signs in front of the term. If it had been the second term, yes, you would. All right, let's take a look at the last example. Once again, I'm going to put on my training wheels of circles and squares to identify my terms. That way I know what I need to combine later. So 3 gets a square. X gets a circle. Excellent. And 8 gets a
Square.
All right. Now I would like to hear from somebody in the back row. I don't let the people in the back hide from me. So what terms do I need to combine in that last example?
8 and 3.
The 8 and the 3. So 8 and 3 are my like terms. Are they on the same side of the equation as one another?
No.
No. So what needs to move?
Subtract the 8.
Subtract the 8. So the 8 needs to move over with the 3 because it's a +8 on the right-hand side. When I move it to the left-hand side of the equation, I write -8. So check to see that you did that you wrote -8. So when you cross those lines, you have to change the sign. All right, we're ready to combine. +3 and -8 are opposite signs, so you have to subtract. 8 minus 3 is 5.
-5.
And don't forget, bigger sign wins. Very good, -5. So equals x. And you have -5 is equal to x is perfectly fine. But again, some of you may want to rewrite that and by flipping it around. And it's the same thing as saying x is equal to -5. It's like saying my name is Stacy and Stacy is my name. You're saying the exact same thing, but standard form we would normally write x is equal to -5. Any questions on combining like terms in an equation? All right, the last type of example is isolating a variable. Now, the difference between combining like terms and isolating the variable is what operations we use. When we were combining like terms, that's when we had to use the adding of integers rules, SOB. When you're isolating variables, though, the numbers that are right beside your variable are directly under, which are called coefficients. You do not use your SOB rules. You're going to use your multiplication and division rules of integers. So some of you may have remembered this using the triangle or the TP to help you remember your positive and negative signs. You would multiply and divide like you normally would, but then if the signs are the same, then your answer will always be positive. If your signs are opposite, your answer will always be negative. So how many of you have seen the TP before or the triangle before to help you? Good. A lot of you have had Math B before and learned how to do this. All right. So to remember what you do with coefficients, there's also another rhyme to help you out to remember these. Everybody repeat at me. Repeat after me, sorry. Under, up, and multiply. Oh, that was dead. Let's try that again. It's Monday, I know. But let me hear it. Under, up, and multiply. Weak sauce. Beside it, divide it.
Beside it,
Divide it. All right. So what that means is if I have a number that's underneath my variable, I'm going to move it up and multiply. If I see a number that's directly beside my variable, I'm going to divide it. Beside it, divide it. If I see both, I need to do both of those steps, but in that order. Under, up, and multiply. Beside it, divide it. So let's take a look at the first example there. X over 2 equals 5. Where's my coefficient? Is it beside it or under it?
Under it?
Under it. So if it's under, I have to do what?
multiply.
Yeah, under, up, and multiply. So I'm going to multiply both sides by 2. So multiply by 2, multiply by 2. These 2's cancel out. That was the whole point of multiplying by 2. So x is equal to, that's 5 times 2. They're both positive.
10.
Equals positive 10. Yeah. That's a dot right there, by the way, if you guys are looking at me curiously. Positive 5 times positive 2 is 10. Do you have a question over there, ladies? Nope. You looked puzzled and bewildered.
Just like number 2, under, up, and multiply don't make sense with that. Like, he has always just told us do the opposite of what it says.
Okay, what is that? If
Multiplication.
it's underneath, that line right there means a fraction.
That
This
means
means
dividing.
x divided by 2. What's
So
the
you
opposite of
multiply.
division?
Right.
Multiplication. So that's why you can either remember it's just the opposite operation, like what you just told me, which is absolutely correct, or you can remember it with the rhyme, under, up, and multiply.
No
Right.
division.
Look at the second one.
Number 2 is
That
division.
3 is beside our y, right? If it's beside it, we have to divide it. So we divide by 3. Divide by 3, divide by 3. The 3 goes underneath our 15.
Yeah, so it's
The 3's cancel out, and you have y is equal to
5.
5. Good. Last one. Okay, what are my coefficients in the last example?
2 and 10.
2 and not quite 10. Somebody else. I agree. 2 is one of our coefficients.
Oh, 5.
5.
5. So we have 2 coefficients in this example. We have the 5 that's directly beside our variable and the 2 that's under it. Do you all see that? All right. Now, to get rid of those, we have to do one at a time. Which one goes first, though?
2.
Yeah. Multiplication.
You got to get rid of that 2 first, right? So if it's under, you move it up and we multiply. So we're going to multiply both sides by 2. The 2's cancel out. You have the 5x on this side. It stays that way. And 2 times 10 is 20. All right. My x is still not by itself, so I'm not done yet. That 5 is beside my x, so if it's beside it, I have to divide it. Divide by 5, divide by 5.
It's 4.
So x is equal to 4. And what's another way to write that?
X equals 4.
X equals 4. Yeah, we can turn it around.
Where?